Welcome to this explainer. Today, we're diving straight into the raw technical blueprint of why modern networking has completely abandoned traditional WAN in favor of SD-WAN. If you've ever wondered how enterprise networks made that massive leap from rigid, expensive physical boxes to these dynamic, software-driven powerhouses, well, you're in the exact right place. We're going to pop the hood and really break down the architecture powering today's hyper-connected world.
So let's kick things off with the core question. Why can modern businesses absolutely no longer tolerate the old way of managing a large network? You know, for decades, traditional wide area networks, WANs, were the absolute backbone of enterprise connectivity. But as businesses scaled up, that old architecture, it just became this incredibly difficult, expensive, and manual burden to maintain. It literally just couldn't keep up with the insane demands of the modern cloud era.
To figure out why, we've structured this explainer into 4 quick sections. First, the flaws of traditional WAN. Second, separating brains from brawn. Third, the 3 technical pillars. And finally, a high-value CCNA cheat sheet.
All right, Section 1, the flaws of traditional WAN. Let's paint a picture of just how frustrating the old system was for both network engineers and end users. Managing a traditional WAN wasn't just hard, it was fundamentally flawed by its own design.
Traditional WAN suffered from a total laundry list of fatal flaws. First off, immense complexity and scale issues, largely thanks to decentralized intelligence. Then, there was the insanely expensive connectivity. Organizations basically felt forced to rely on private MPLS circuits. That's multi-protocol label switching, right? Because standard broadband internet was considered completely untrusted for critical traffic. Third, we had application blindness. Routing decisions were made based entirely on destination IP addresses using these rigid static rules. The router literally had no idea if it was handling a crucial CEO video meeting or just some random background file download. And finally, all of this led to highly inefficient traffic paths.
Just look at the manual nightmare of the old way when dealing with that complexity and scale. To add just one single new branch to the network, an engineer was stuck doing line-by-line command line configuration. Good old CLI. They had to manually log into that specific router, carefully copy over the config, test it to make sure nothing broke, and then repeat that whole exhausting process for every single branch. Because the control plane was distributed across all these isolated boxes, the process was agonizingly slow and honestly highly prone to human error.
And for the end users, the experience was definitely not much better. This inefficient routing meant everyday users suffered through laggy Zoom calls and super slow access to cloud tools like Office 365 or Salesforce. Why? Because of this awful thing called hairpinning. Branch traffic had to detour all the way back to its central headquarters just to get security screening before it was even allowed out to the internet. It introduced a massive, totally unnecessary amount of latency into the system.
Moving on to Section 2, separating brains from brawn. So how do we fix a system that's manual, blind, and completely clunky? Well, we completely redesigned the architecture by applying the principles of software-defined networking. Here is our hero concept. SD-WAN solves those traditional WAN problems by splitting the network into 2 distinct layers. It completely decouples the physical hardware from the software intelligence. Let's look at the data plane first. This is your physical layer, the brawn. These are the actual physical routers like a Cisco ISR or Catalyst 8000, sitting at a branch or data center. In an SD-WAN, they now do only one thing: forward packets. No built-in intelligence. They just receive instructions and execute them. On the flip side, we have the control and management plane. That's the intelligence layer, or the brain. The brain is ripped completely out of those physical routers and centralized into a software controller. This is usually hosted in the cloud or a secure data center, letting you manage the entire network from one single dashboard. This decoupling is absolutely crucial. By taking the routing logic out of the individual hardware boxes and pulling it up into that centralized software dashboard, we're establishing the absolute foundation of software-defined networking. I mean, without this specific decoupling, literally nothing else we are about to talk about is even possible.
All right, Section 3, the 3 technical pillars. Now that the brain is centralized in the cloud, and the brawn is just blindly following orders down below, let's check out the superpowers this architecture unlocks. These are the big 3 features that totally separate SD-WAN from traditional networking.
With our first pillar, Centralized Management, we get incredible scale. Picture a network administrator sitting at just one computer, looking at a single pane of glass, like Cisco's vManage. Instead of logging into routers one by one using the command line,
That admin can now create a single configuration template and push it out to 10 or even 1,000 routers simultaneously with just one click. The time and money saved here is absolutely staggering.
Our second pillar is transport independence. Remember how traditional WANs were basically chained to those really expensive private MPLS circuits because broadband was considered untrusted? Yeah, SD-WAN fixes that entirely. SD-WAN routers are totally transport agnostic. They honestly don't care if you plug in an expensive MPLS line, a cheap broadband internet connection, or even a 5G signal. The software treats them all exactly the same. It does this by creating a highly secure virtual IPsec tunnel perfectly layered right on top of whatever physical transport you happen to be using. And that builds right into our third pillar, which totally eliminates that old application blindness problem. Application-aware routing. This is a massive game changer. Because the intelligence is centralized, SD-WAN controllers can deep scan the packets passing through the network. They instantly know if a packet is a sensitive VoIP call, a live video feed, or just bulk data. Then, based on the policies you set, the network dynamically and intelligently routes that different traffic over different links, making split-second decisions based on real-time network performance.
Let's pull those big three together right here. These pillars are the ultimate payoff of SD-WAN. We've got centralized management giving us one-click scaling from a single dashboard. We've got transport independence giving us the total freedom to use MPLS, broadband, or LTE securely via IPsec tunnels. And we have application-aware routing, making sure your most important traffic gets priority based on real-time conditions. It completely transforms this rigid, hardware-bound, manual network into a really dynamic, intelligent, and automated software system.
Okay, moving to Section 4, the CCNA cheat sheet. Let's rapid-fire through the exact terminology you're going to need. Whether you're studying for a CCNA exam or just want to sound like the smartest person in your next IT meeting, you need to know these raw technical concepts cold. First up, the control plane. Remember, this is the brain determining the rules of the road. It handles the logical part of the network, all the routing logic and security policies. The big takeaway here is that in SD-WAN, this control plane is completely centralized in a controller, instead of being scattered across 1,000 different branch routers.
Next, the data plane. This is simply the physical brawn. We're talking about the edge devices, the actual physical hardware routers sitting in those server racks. They literally do nothing but forward packets exactly as they're instructed to by the control plane.
Then we have the management plane. Think of this as your steering wheel and dashboard. It's the actual user interface, like Cisco vManage. This is where you, the administrator, actually sit down to build those brilliant templates and push configurations out to the entire network with a single click.
Now for the architecture itself. The overlay network is where the actual magic happens. This is the virtual software-driven network that the SD-WAN software creates using secure IPsec tunnels. It's totally application-aware and transport-independent. Just think of it as an invisible, intelligent web layered right over your physical connections.
Conversely, the underlay network refers to the literal physical connections transporting those virtual overlay tunnels. We're talking about the actual copper wires, the fiber optics, the cell towers. It's that specific MPLS circuit you bought, the standard broadband wire coming into the building, or the LTE signal hitting the antenna.
And finally, tying those last two terms together, transport independence. This is that brilliant capability to run your intelligent overlay network across absolutely any physical underlay. It treats a cheap broadband connection and an expensive MPLS line exactly the same, as perfectly valid secure data paths to route your traffic.
So, as we wrap up this explainer on why SD-WAN has completely replaced traditional WAN, I want to leave you with a final thought. We've just seen how massive this paradigm shift of decoupling intelligence from hardware truly is, right? We literally took the brain out of the router and threw it into the cloud. So as networking continues to become entirely driven by this highly intelligent software, take a look around your server room. What piece of legacy physical hardware is destined to become obsolete next? Thanks for joining me on this deep dive. I hope this gave you a really clear blueprint of modern SD-WAN architecture.